Diane Zhu, and this is my presentation on Lab 1 charge tapes. The purpose of this lab is to observe the movement and transfer of electrons between pieces of tape and calculate the change in charges. Some important fundamentals are tape modeled as point charges with equally distributed charges, so Coulomb's law can be applied. Newton's second law, F equals m times A, Coulomb's law, F equals k times q1 times q2 divided by r squared, and by approximating the size of the atoms, we can calculate the excess amount of electrons on a charged piece of tape. And the result is due to the repulsion between the two positively charged objects, the steady piece of tape began to float. The models for this lab is each piece of tape was modeled a point charge, allowing for observation of the effects of electric charges between the tapes. Some assumptions I made throughout the lab are air resistance is negligible, charges are evenly distributed along the tapes, and each piece of tape initially has neutral charges until ripped off the table. And regarding the description of the experiment, the system is the two pieces of tape, surroundings is everything else around it. The initial condition is there are a total of 3 pieces of tape, 2 pieces of tape of equal length, and 1 piece of tape is stuck on the desk, and we expect that the 2 pieces of tape would repel each other, and the following 4 steps are the procedure to the experiment. Some observations we made throughout the lab are U-tape was repelled by the other U-tape, the U-tape was attracted by my hand and any other neutrally charged atoms, for example my book, the U-tape was attracted to the negatively charged pen. From this we can conclude that the tape lost electrons and became positively charged after being pulled away from the other piece of tape. Some data and calculations we made throughout the lab. The tape mass is 0.0018 kilograms, tape length is 0.18 meters, tape width is 0.019 meters, distance between the tapes is 0.034 meters, force of grav we calculated to be 0.001764 newtons, charge on tape, assuming there's no accelerations which lead to F grav equals F electric field, we calculated to be 1.503 times 10 to the negative 8 coulomb. Number of electrons lost we calculated to be 9.385 times 10 to the 10. Area of tape, length times width equals 0.00342 meters squared. And the area of atom we calculated to be 1 times 10 to the negative 20 meters squared. And regarding coding for part 1, you can see I have all the variables listed on the right hand side. Too easy for use when calculating using the formulas on the bottom. You can see that we were able to calculate the magnitude of gravitational force, the magnitude of electric force, the charge on the tape, the number of electrons, the number of atoms, and the ratio of electrons to atoms. And to answer the question for coding part 1, what was the magnitude of the charge on one piece of tape as calculated by your first computational model? Our answer is 1.50601 times 10 to the negative 8. And regarding coding part 2, using the function and the electric field formula, we were able to calculate electric field for the charged particle. And to adjust the position of the top tape, we replaced the y value of our distance value, which is 0.034, and using the code on the bottom, we were able to calculate the magnitude of electric force and the magnitude of gravitational force. And to answer the question for coding part 2, our answer is 1.42254 times 10 to the negative 3. And some discrepancies of the model is not real charge points, and the charges on the tape are most likely not equal. Some source of errors are more charges could have been lost during the handling of the tape, margin of error on measurements, and any other possible human errors during the experiment. And the answers to what if and why questions are the observation would essentially be the same thing, but the polarity of the tapes would reverse, so it would be negative instead of positive. And for the answer to the why question, they are different because the tapes are being treated differently in the computational models. And the second one would be more accurate because the tape is being treated as the entire length of tape is charged instead of just being a point in charge. And thank you.